We're going to look at solving linear inequalities, and we're also going to look at different types of linear inequalities, including compound inequalities. Now, you may have learned to solve linear inequalities in the past, but here we're going to look at solving them using test values. So let's look at our first example. 2 times the quantity 1 minus x plus 5 is less than or equal to 3 times the quantity 2x minus 1. So our first step will be to write this as an equation and then solve the equation. So I'll rewrite this as 2 times the quantity 1 minus x plus 5 equals 3 times the quantity 2x minus 1. To solve this, we'll start by distributing. 2 times 1 is 2. 2 times negative x is minus 2x plus 5 equals, and then we'll distribute again. 3 times 2x is 6x. 3 times minus 1 is minus 3. We'll combine our like terms, so 2 plus 5 is 7, minus 2x equals 6x minus 3. I'll bring my x terms to the left. I'll do that by subtracting 6x from both sides. Then I'll get 7 minus 8x equals negative 3. Now I'll bring my constants to the right. I'll subtract 7 from both sides. Then I'll get negative 8x equals negative 10. We almost have x by itself, so let's now divide both sides by negative 8. So we're dividing a negative by a negative. The negatives cancel and they become positive. And I can also cancel 2's out of 10 and 8. So 10 divided by 2 is 5. 8 divided by 2 is 4. So x equals 5/4. Next step, we'll draw a number line and we'll place the value that we just found on the number line. We'll use a closed-in circle if we had it less than or equal to or greater than or equal to in our original inequality. And we'll use an open circle if we had a less than or a greater than. So here's our number line. We have negative infinity to the left. We have positive infinity to the right. Our original inequality, we had a less than or equal to, so we had the equal bar. We will include our 5/4, so we'll have a closed-in circle. And I'm just putting the 5/4 on there. Our next step, we're going to choose test values on either side of this value. And then we'll put the test values into the original inequality to determine which intervals the inequality is true or false for. So on the left of 5/4, I'm choosing 0. I could have chosen 1, but 0 is an easy number to work with. On the right of 5/4, I'm choosing 2. Again, 2 is an easy number to work with. Okay, so I'm just redrawing that so that we have room to test our test values. Let's test the 0. So substituting in, I have 2 times the quantity 1 minus 0 that got substituted in, plus 5. Is that less than or equal to 3 times the quantity of 2 times 0 minus 1? Let's simplify. 2 times 1 minus 0 is 1, plus 5, less than or equal to 3 times 2 times 0 is 0 minus 1, negative 1. So I have 3 times negative 1 on the right-hand side. Let's simplify further. 2 times 1 is 2, plus 5 is less than or equal to 3 times negative 1 is negative 3. On the left, 2 plus 5 is 7, so now I have 7 is less than or equal to negative 3. Is this true or false? This is false. So on the interval where we have our test value of 0, I'll write false. Let's test the 2. So we'll substitute 2 in for x now. 2 times the quantity 1 minus 2 that got substituted in, plus 5. Is that less than or equal to 3 times the quantity of 2 times 2 minus 1? Let's simplify. 2 times 1 minus 2 is negative 1, plus 5, less than or equal to 3 times the quantity. 2 times 2 is 4, minus 1 is 3, so we have 3 times 3 on the right-hand side. Let's simplify further. 2 times 1 is negative 2, plus 5, less than or equal to 3 times 3 is 9. On the left-hand side, negative 2 plus 5 is 3, less than or equal to 9. 3 is less than or equal to 9, so this is true, and I'll write true on this interval on the number line. So our next step is to shade the true intervals on the number line. So this is including the 5/4 since that was included, and I'm shading to the right because that's where I had marked true. Now we'll write our solution. So we had shaded to the right of 5/4. Those were the x values that were greater than or equal to 5/4. This is our solution as an inequality. If I were to write my solution in interval notation, I always write smaller number, comma, larger number. So 5/4, comma, in this case it's pointing towards infinity. 5/4 gets the squared off bracket because it was included. Infinities always get curved parentheses. Okay, let's look at some compound inequalities. Those are ones that include and or. So example 2. 3x minus 1 is less than 8, or x minus 5 is greater than or equal to 0. Okay, basically the same first step. Rewrite as equations and solve. So I'll rewrite this as 3x minus 1 equals 8, or x minus 5 equals 0. I'll add 1 to both sides on this first one, and I'll get 3x equals 9. Divide both sides by 3, I get x equals 3. On the second one, I'll add 5 to both sides, and I'll get x equals 5. Then I'll draw a number line, and I'll plot these two solutions. So I've got my number line. Negative infinity is to the left, positive infinity is to the right. I've got 3 and 5. Now 3 came from the inequality that had the less than. So no equal bar. 3 is not included. I'll put an open circle. The 5 came from the inequality that had the equal bar. It was a greater than or equal to. So it is included, and I'll put a closed circle. Okay, now we'll choose our test values and test them in the original. So to the left of 3, I'm choosing 0. I could have chosen 1 or 2 as well, but 0 is easy to use. Now I also need to choose a value between 3 and 5. I'm choosing 4. And a value to the right of 5. I'm choosing 6. So there are 3 intervals here, and you can see that if I break my number line where I have my values plotted. So I have my first interval here, my second in between the 3 and the 5, and the third to the right of the 5. Let's test the 0 first. So 3 times 0 minus 1 less than 8, or 0 minus 5 greater than or equal to 0. 3 times 0 is 0, 0 minus 1 less than 8, or 0 minus 5 is negative 5, negative 5 greater than or equal to 0. 0 minus 1 is negative 1, so I have negative 1 less than 8, or negative 5 greater than or equal to 0. Negative 1 is less than 8, that is true. Negative 5 is not greater than or equal to 0, that is false. But with or, for it to be true, one or the other or both can be true. The only time an or statement is false is if both statements here are false. So because one of our statements is true, this or statement is true. So I will put true on the interval where we got our test value of 0. Let's test the 4. Substituting in 3 times 4 minus 1 less than 8, or 4 minus 5 is greater than or equal to 0. 12 minus 1 less than 8, or 4 minus 5 is negative 1, greater than or equal to 0. 12 minus 1 is 11, so I have 11 less than 8, or negative 1 greater than or equal to 0. 11 is not less than 8, that is false. Negative 1 is not greater than or equal to 0, that is also false. So both of these statements are false. So for an OR statement, when both are false, then the OR statement is false. So I will put false on the interval where we got the 4 test value. Let's test the 6. 3 times 6 minus 1 less than 8, or 6 minus 5 greater than or equal to 0. 3 times 6 is 18, so 18 minus 1 is less than 8, or 6 minus 5 is 1, so I have 1 greater than or equal to 0. 18 minus 1 is 17, so I have 17 less than 8, or 1 greater than or equal to 0. 17 is not less than 8, so that is false. But 1 is greater than or equal to 0, so that is true. Again, with an OR statement, if at least one of the statements is true, then the OR statement is true, so this one is true. And I will write true on the interval where we got the 6. So now we will shade the intervals where we wrote true. So I have one true, a second true, so I have 2 intervals. I have the one pointing to the left and the one pointing to the right. Okay, then we will write our solutions. I'm going to squeeze that in up above. So the one to the left is shading in all the x values less than 3. So remember 3 is not included. Or, and or is part of the solution, x is greater than or equal to 5. So the 5 is included, so we do need the equal bar. In interval notation, remember smaller number comma larger number, I have negative infinity comma 3. Infinities always get a parenthesis. 3 is not included, so it gets a parenthesis. Or is a union symbol in interval notation. And then the right shaded interval, we're starting at 5, going to positive infinity. 5 is included, so it gets a squared off bracket. Infinities always get curved parentheses. Okay, example 3. This one is an AND inequality. So we have 5x minus 2 is less than or equal to 3 and 4x plus 7 greater than 3. So same first step. Let's rewrite these as equations and solve. So I'll rewrite as 5x minus 2 equals 3 and 4x plus 7 equals 3. Solving, I'll add 2 to both sides. I get 5x equals 5. I'll divide both sides by 5 and I'll get x equals 1. On the second one, I will subtract 7 from both sides and get 4x equals negative 4. I'll divide both sides by 4 and get x equals negative 1, and I do have an and in between them. Let's draw our number line. So I have negative 1, and that came from the inequality that had the greater than, which did not have the equal bar, so this negative 1 is not included. It gets an open circle. And I have a 1. Now remember, on the number line, we are plotting the smaller number to the left and the larger number to the right. So the 1 came from this inequality, which had the less than or equal to, so it is included. It has the equal bar, so we're putting a closed circle. Let's choose our test values. To the left of negative 1, I'm choosing negative 2. Between negative 1 and 1, I'm choosing 0. To the right of 1, I'm choosing positive 2. Let's test them. So testing negative 2, I've got 5 times negative 2 minus 2 less than or equal to 3, and 4 times negative 2 plus 7 greater than 3. It becomes negative 10 minus 2 less than or equal to 3, or negative 12 less than or equal to 3. On the second one, I've got negative 8 plus 7 is greater than 3, which becomes negative 1 is greater than 3. So this first one, negative 12 is less than or equal to 3. That is true. And negative 1 is not greater than 3. That is false. For and to be true, they both need to be true. If any of them, even if it's just one, is false, then the and statement is false. So because we have at least one false statement, this and statement is false. So I'll put false on the interval where we got the negative 2. Let's test the 0. Okay, 5 times 0 minus 2 less than or equal to 3. And 4 times 0 plus 7 greater than 3. Becomes 0 minus 2 is less than or equal to 3. Or negative 2 is less than or equal to 3. The second one becomes 0 plus 7 is greater than 3. Or 7 is greater than 3. Okay, so we've got and in between those two. Negative 2 is less than or equal to 3, so that first one is true. 7 is greater than 3, so the second one is true as well. Both of these statements are true, so this and statement is true, and I will write true on the interval where we got the 0 test value. Let's test the 2. Substituting in, 5 times 2 minus 2 is less than or equal to 3, and 4 times 2 plus 7 greater than 3. This becomes 10 minus 2 less than or equal to 3, which becomes 8 less than or equal to 3. The second one becomes 8 plus 7 greater than 3, or 15 greater than 3. Okay, there's an and in between them. 8 is not less than or equal to 3, so that is false. 15 is greater than 3, so that is true. We have at least one false statement in this and, so this and is false, and I will write false up here on the interval where we got the 2 test value. So I'm going to shade in. So we've got this negative 1 that's not included. We've got the positive 1 that is included, and our true interval is in between those values. And then writing our solution, we've got x in between negative 1 and positive 1. But we have negative 1 is less than x is less than or equal to 1. So there's no equal bar by the negative 1, but there is the equal bar by the 1. That's inequality form. And interval notation, I go from negative 1, comma 1, because smaller comma larger. Negative 1 is not included, so it gets the curved parenthesis. Positive 1 is included, it gets the squared off bracket. Let's look at one more example, which is sometimes called a tripartite inequality or sometimes a sandwich inequality, which is basically just another form of an and. So for example, negative 5 less than or equal to 4 minus 3x less than 2. So we have 3 parts of the inequality. So here we're going to separate it into 2 separate inequalities with an and in between. We're going to rewrite it as negative 5 less than or equal to 4 minus 3x and 4 minus 3x less than 2. And now we'll continue as we did before by rewriting these as equations and then solving them. So negative 5 equals 4 minus 3x and 4 minus 3x equals 2. So subtracting 4 from both sides on the first one, we get negative 9 equals negative 3x. Dividing both sides by negative 3, we get x equals 3. On the second one, if we subtract 4 from both sides, we get negative 3x equals negative 2. Dividing both sides by negative 3, we get x equals, the negatives cancel, we get x equals positive 2/3. Okay, so we'll draw our number line. I've got 2/3, and the 2/3 came from the inequality that was less than, so it gets an open circle. I've got 3. 3 comes from the inequality that had a less than or equal to, so it is included. It gets the closed circle. Choosing test values, to the left of 2/3, I'm choosing 0. Between 2/3 and 3, I'm choosing 1. To the right of 3, I'm choosing 4. But again, you could choose any numbers in between on these intervals. You can't choose the actual solutions we've already plotted, but you can choose any numbers on those intervals. I'm choosing easy ones. Let's test the 0. So substituting in, I have -5 is less than or equal to 4 minus 3 times 0, and 4 minus 3 times 0 less than 2. So first one becomes -5 is less than or equal to 4 minus 0, or -5 is less than or equal to 4. That is true. The second one becomes 4 minus 0 is less than 2, or 4 is less than 2. That is false. So this is an and statement, and we have at least one false. That means this and statement is false. So I'm marking the interval that we got the 0 test value from as false. Let's test the 1. Substituting in, I have -5 less than or equal to 4 minus 3 times 1, and 4 minus 3 times 1 less than 2. -5 less than or equal to 4 minus 3, which becomes -5 less than or equal to 1. That is true. The second one becomes 4 minus 3 less than 2, which becomes 1 less than 2. And that second one is also true. So both of these are true. So that and statement is true. So I will mark this middle interval as true. Let's test the 4. Substituting in, -4 less than 4 minus 3 times 4, and 4 minus 3 times 4 less than 2. The first one becomes -5 less than or equal to 4 minus 12, or -5 less than or equal to -8. That's false. The second one becomes 4 minus 12 less than 2, or -8 less than 2. That is true. So this is an and statement where at least one of them was false, so that makes this false. And I will mark the interval where we got the 4 test value as false. So we have one true interval, which was that middle one. So I have the open circle around the 2/3. I have that closed circle around the 3, and I'm shading that middle interval. Writing my solution, I've got 2/3, I've got x in the middle, I have 3. Because 2/3 was not included, I have less than. Because 3 was included, I have less than or equal to there. So I have 2/3 less than x is less than or equal to 3. That's inequality form. For interval notation, smaller number comma larger number. So 2/3 comma 3. 2/3 is not included, so curve parenthesis. 3 is included, squared off bracket. So there's my solution.